Hey guys, welcome back to my channel. In today's video, we are going to see how to solve this problem called longest subarray with sum k, right? Again, this is a brute force solution. So in last video, we have discussed the same question, but we have done using brute force approach, right? So the solution was of n cube at first, then we optimized it to of n square. But in this, we are going to solve it using O of n, right? So these two approaches were the brute force, and this approach is the optimized one, which I am going to discuss in this video, right? So again, it's not for negative elements. We are considering that all the elements are either positive or zeros. If there is negative, the approach which we are going to discuss right now will not work. Then you might be asking, bro, what about the negative elements? What if negative element comes? So for that, I'm going to make other video in which we will be using a space of n, which will be discussed in the next video, right? So in this video, we are considering all the elements are either positive or zeros. So let's look into the question, right? So let's say this is the array given 1, 4, 2, 1, these all are the elements. So I have to get the longest subarray with sum k. Again, what is subarray? I have discussed in this video. So longest subarray, right? So let's do one thing. Let's take all the subarrays that gives the sum. So this is the subarray that gives the sum 3, and again 1 2 gives 3, 3 0 gives 3, 0 3 gives 3, 3 0 again gives 3. Here 1 1 1 will also give 3, 0 1 1 1 will also give 3 as their sum, right? So let's take all the lengths. So the lengths are 2 2 2 3 4. We have to find the longest subarray with sum k, right? So longest will be this, having length 4. So your answer will be 4, right? Similarly, in this example, let's say k equals to 2. So these all are the subarrays that we can make, keeping in mind that summation of all the elements inside the subarray will be k, that is 2 in this case, right? So let's take the longest among that is this one. So our answer is 4, and we got the answer, right? So we are going to approach this using 2 pointers. So how we are going to approach? I want you to assume in a generic way, right? That's the reason I didn't write any numbers here. I just gave some dots, considering that these all are some positive numbers or zeros, right? So what I'm going to do, I'm going to take summation from LHS to the RHS. Basically, I'm just going to get the summation of all the elements from left to right, and then the moment I get a sum that is greater than k, the moment I get a sum that is greater than the required sum, is there any point going forward again? Because see, if the sum is more than k right now only, even if I take all the elements that is in the right hand side of me, it will still be more than k, right? But what I want, the sum should be equals to k. So this condition will never appear, right? Because sum will be always greater than k. If I keep on going to the right hand side, if sum is greater than k right now, right? So there is no point in going ahead. So what I'm going to do, I'm going to trim down some of the elements from the back side, right? So since we need subarray, we can't remove any elements like from here. So we are removing elements from the back side, keeping in mind that we are having a subarray, right? So basically we are going to reduce the size, but from left side, right? So the subarray will be till here. If still summation is greater than k, remove this element also. So subarray will be till here, right? So we will be shrinking the window size from left hand side if the sum is greater than k, right? So that's what I have shown here. 2 pointers are used, left and right. basically if there is a subarray, left pointer will be pointing to the starting of the subarray and right pointer will be pointing to the ending of the subarray, right? So let's have a dry run on this example. So at first I'm going to keep something like L equal to 0 and R equals to 0, right? So this is the subarray that is being formed, right? So here the sum is basically 1, right? So bro, what I'm saying, don't do anything, go ahead. So R will come here. Now summation is basically 5. 1 plus 4 will give 5, which is greater than K, right? What is K? What is K? K have taken 3, right? And along with this, I'm maintaining a max length, right? Where I'm going to store the answer. So K is basically 3, but bro, we have 5, which is greater than 3. So what we are going to do, we are going to shrink this pointer. So before this was the subarray, but right now subarray is this. Now sum is equals to 4. It is still greater than K, right? So I'm just reducing it and now there is no subarray. So sum is basically 0. So in the next iteration, I am incrementing R and I formed this subarray. So here summation is 2, which is lesser than K, right? So don't do anything, increment R, right? So keep on going, keep on going. So next time R will come here and sum will be 3 and bro, 3 is equals to K. So I got that subarray that has sum 3, right? So take out the length and please put it in the max length. Before it was 0, right? We initialized it with 0. Right now we got a new length that is greater than 0. So max length will be 2. Okay, you might be wondering how to find length, right? So length you will get by right minus left plus 1. This will give the length, right? So okay, we got this max length, new max length. Let's move forward, right? Again, I'm incrementing R. So R will come here. The moment R comes here, the summation will be 5 and it is greater than K. So I'm going to shrink the window. So the window will be this now. So summation is again 3. So length is 2. Before also 2 was there. So no change, right? So again R will move ahead. Now summation will be 6 and sum is greater than K. We will reduce it from the back side. So now the subarray will be only till here. Still sum is 5. Still it is greater than K, right? So reduce again. So now subarray is this. Now sum is 3 but length is 1. But bro, we have the maximum length to be 2. So don't do any changes in this. Go ahead with the next iteration, right? So R will increment. So we got this subarray and the sum is 3 and the length is 2. 2 already we have. So no change. Again go ahead. R is there. Now this is the subarray. Sum is 6 which is greater than K. So shrink from the left side. So now new subarray will be this. Sum is 3. We got the K but the length is 2. We already have 2. So no change. Again move ahead with the right pointer. Here this is the new subarray and sum is equals to 3 but length is 3. So length is more than the previous length. So I'm going to store the maximum, right? So 3 will be here and now go ahead with the next iteration. So R will go ahead and right now this is the subarray but the summation is 4 which is greater than K. So I'm going to shrink the window size from left hand side. So the window will be till here. So sum will be 4 and it is still greater than K, right? So bro, shrink again. Now sum will be 1 which is fine. So go ahead with the next index. Now the window is still here. Sum is 2. Go ahead. Go ahead. R comes here. And the window or the subarray is this. Sum is 3 again. But this time length is 4, right? So before length was 3, now we got 4. So maximum of these two will be 4. So we are updating the max length, right? So in the next iteration, R will go outside, right? So when the R will become N, we are going to end the loop, right? So basically what we are going to do, we are going to run a while loop and do these operations. But inside this, I'm writing, bro, right pointer should be lesser than N, right? I'm going to write. So now let's have a look at the code. The code is the implementation of what I have shown in the dry run. So first left pointer and right pointer will be initialized with 0, first position, right? And then I'm keeping a track of sum, then max length also, right? So while right is lesser than N, I'm going to go inside this loop. Here I'm going to update the sum with sum equals to previous sum plus current element of right pointer. As the right pointer moves ahead, we have to add that to the existing sum, right? So we are doing that here, and this part will be the shrinking part. So basically when left is lesser than right and sum is greater than k, at this point what I'm going to do, let's say these all are the elements, and from here to here our window size is there, right? So left is there, right is there, we have the summation, let's say s. So what I'm going to do, I'm going to remove this element from the sum. So sum equals to sum minus a of left, and then I'm going to change the pointer to the next value. So L plus plus will come, right? So that's the same thing that I have done here. I decremented the sum and then I incremented the left pointer. So this will keep on going when the sum is greater than k, right? So after this we are going to check if sum is equals to k or not. If it is equals to k, then I'm going to calculate the length and compare it with the max length, and whichever is maximum among them, it will be stored in max length. After that I'm just incrementing the right pointer. So at the end, max length will be having the maximum length of subarray that has sum equals to k, right? So here the time complexity will be of n. Why? Because this loop will run for of n. But to be specific, we are visiting an index twice at the worst case, right? Because let's say this is an array. So right will go from starting to ending. Left will also move from starting to ending at the worst case. So it will be n plus n, which will give 2n. But again, ignoring the constant, you will get n only. So time complexity will be of n and space complexity will be of 1, since we are not using any extra space, right? So that's it for the video. If you like the video, hit the like button, subscribe to our channel. Until next time, see ya.